Imagine a world where factories and warehouses can operate with precision and efficiency beyond human capability, where machines can see as clearly as or even better than humans. AI powered vision software is making this world a reality, solving long standing industry challenges and setting new benchmarks for flexibility, accuracy, and operational efficiency. Welcome, everyone, to another exciting episode of Analytics Insight podcast, where we explore the cutting edge technologies that are reshaping industries worldwide. And I'm your host, Priya Dayalani. Now, the realistic conception of AI in manufacturing looks more like a collection of applications for compact, discrete systems that manage specific manufacturing processes. Now, they'll operate more or less autonomously and respond to external events in increasingly intelligent and even human like ways, events ranging from a tool wearing out, a system outage, or a fire or natural disaster. So, what exactly is AI vision powered software, or what is the role of artificial intelligence in manufacturing and factory flows? To help us guide more into this vast topic area, we have Puru Rastogi, co founder and CEO of Mowito, and we'll be diving deeper into the innovative solutions that AI powered vision software can help transform factories and warehouse automation. Hi Puru, how are you doing?
Hi Priya, I'm doing good. Glad to be here. How are you?
I'm doing good too. Thank you so much. It's a pleasure to have you with us on a podcast. And of course, we'll be diving deeper into the aspects that I shared and mentioned earlier. But before that, we would like to know more about Movito. If you could help us understand about the company, its specialization, and if there's any specific solution the company is catering to.
So Mowito is a software company and we develop generative AI software that enables robotic arms to perform all sorts of complicated tasks. We aim to automate more and more processes inside, warehouses and factories. We want to increase the adoption of robotic arms, and that is why we are building this software so that we can decrease the cost of expenditure, we can decrease the operational expenditure, cost of production, and increase the quality of production inside factories and warehouses. And starting from factories and warehouses, we eventually want to, bring robots to daily lives of people, be it hospitals, be it hotels, be it old age homes, everywhere. That's what Movito's mission is, to bring robots to to increase the adoption of robots and bring robots to everyday life of people.
Great, quite motivational and inspiring, I must say, when listening or understanding about the company's entire vision. And of course, how we would be doing that, we'll be discussing in the data aspects of the podcast. Having said that, we would also like to know more about you, Puru. I think you have a core expertise that ranges from analytics, strategic thinking, sales planning, forecasting, financing, resource allocation. I think it is just a tip of the iceberg. So, can you help us know more about yourself? How has the journey been till date? What is your exact role and contribution towards a company, or probably, what brought your interest towards this particular vision that you shared with us?
Yeah. So yeah, I'm the co-founder of Mowito, and a little about my background is I graduated from IIT and then went on to do my master's from Carnegie Mellon, specializing in robotics. I've worked for two robotic companies. Both of them were startups. I made their first set of products. I have patents on it. This was in US, and then I came back to India to increase the adoption of robots in India. I realized I can make a bigger impact in Indian robotics. I came back to India around in 2019, did bunch of experiments with my co-founder Aditya, tried out multiple different ideas in robotics. Then eventually we settled on to doing what we are doing today, that is making software for robotic arms, AI software for robotic arms. And in Movito initially, I was primarily focused on the tech, building the first set of algorithms, core technology. Now I'm more focused on R&D, product development, partnerships, fundraising in this area. Apart from that, one of my key focus is also hiring. So I'm always on the lookout for amazing, talented engineers in AI, computer vision, robotics. So that's what I do.
Diverse profile, I must say, Puru. Thank you for sharing that. And of course, it's interesting to being like a co-founder, being more involved into all the different strategic areas that probably one needs into business. Of course, it's like more hands into different departments and areas. But moving ahead, like let's start or begin by understanding the current landscape of the entire manufacturing landscape, I think. So I think traditionally factories and warehouses, have had to navigate a series of persistent challenges when it comes to automations, when it comes to adopting that technology. And efficiency has always been the name of the game. Now, getting like products out faster, reducing waste, optimizing labor. But the road to achieving these goals is filled with a lot of obstacles, especially when you're talking about the manufacturing sector, because all of these goals somehow they depend on a lot of factors. So, what are the key challenges that these factories and warehouses face today? And how do you think that Movito is able, or, Movito's specific technology is able to address them?
See, a short answer will be that the automation which is today present in warehouses and factories cannot deal with the ever-changing environment of these areas. Right? They are very rigid, inflexible, and they work in a very defined manner. For example, I mean, factories have been at the forefront of adopting automation. In fact, the first set of robots were made for factories. So factories got the robotic arms way back in 1980s, 70s. The only issue is that these robotic arms, although they can be reprogrammed, but uh, they have to be very tightly configured. That is, they can, for example, they can pick an object from a particular location, particular orientation, and place it at a different orientation and position. If you change anything in this, be it the position, orientation, or the object, the robotic arm will not be able to function. Right? Simply because robotic arms are by default blind. They do not have any intelligence either. So they do exactly what you tell them to do. And this limits the kind of operations that you can automate through robotics. Um, and because of this, this has been hindering the adoption of robotics in factories as well as in warehouses. So in factories, you will see only automotive factories which have a very, very high production rate. They are using robotic arms. Other factories are not using it. MSMEs are not using it, right? Simply because it takes a lot of infrastructure to automate any process through robots. So that has been hindrance in wide adoption of robotic arms, wider adoption of automation in general. And warehouses comes next. Warehouses have much more variations. In factories, at least you are making one single product all the time for the next, 1 month or 2 months at least. In warehouses, especially in the e-commerce warehouses, you have a variety of products. If you go to Flipkart, Amazon, all these big e-commerce companies, they will have millions of products inside a single warehouse. And creating program for robot arm which can make these robot arm pick and manipulate all these different kinds of product is challenging, and it was not possible till now, till very recently. What Movito is doing, what we put a camera on the top of a robotic arm. We take the feed from these cameras and we use these camera feed to control the robotic arm essentially, right? So we give brains to the robotic arm. The camera is a simple camera which anybody can buy, right? It's a typical, 5-10 megapixel camera which you can buy from anywhere off the shelf. But the intelligence, the computer, the AI model which runs this is made by Movito. Right? So Movito makes this AI model which can make these robotic arm pick a variety of object from any kind of position, any kind of orientation, manipulate them to do the task which is required. So it could be in warehouses, it could be picking and packing. You pick the object from a storage box containing multiple units of that object, and you then pack it in a box which will be delivered to the customer. Right? That's like one task. In factories, it could be other tasks such as assembly. If you are getting an engine, you have to put multiple parts on the top of that engine. An engine could be moving, engine could be in any orientation. The parts which you're picking up from a box, could be stored in a heap, could be stored in a cluttered environment, could be stored in a non-structural manner. So it could be a clump of multiple small parts. From there, the robotic arm has to pick it up and put it on a bigger assembly, let's say an engine. So we make that possible. Before us, traditionally the way it was being done was that the part which needs to be picked has to be placed in a certain orientation at a certain location. With Movito, it can be placed in any position, any orientation in a heap, and robotic arms still will be able to do it. So this decreases the cost of infrastructure which is required for automation. It enables multiple processes to be automated through robotic arms. It decreases the time to install the automation. So today, if one assembly line is making engines and you have any changes in the engines, so for the first 6 months you made the variant one, next 6 months you want to make the variant two. Earlier, it would have taken a lot of time to reconfigure the whole system for making second variant of the same product. Now you don't need to do that. With Mowito, you can quickly reconfigure it. So these are the things which we are doing. Of course, automation is required to decrease the cost of operation, decrease the dependence on the human labor. What Mowito enables is wider adoption of these automation solution by making them flexible, by making them easily reconfigurable, by making them robust to changes in the environment, be it the position of the product, orientation of the product could be moving, the shape and size of the product could be changing, the lighting could be changing. You can change a lot of things and still the automation will work because of Mowito. So this is what Mowito brings to the table: flexibility, robustness, and reconfigurability.
Great. That was a great overview of the challenges that you shared and also a very comprehensive understanding of how Mojito aims or tries to, overcome these challenges that factories and warehouses face today. I also liked your point that, these, historically, if we talk about, the automation systems, you mentioned that, they're pretty rigid. And of course, because, they are designed for a particular task only. Now, for example, robots might be excellent at performing a repetitive task like placing an object on a conveyor belt, but not so good at adapting to changes. So, if a different shape or size object suddenly enters a production line, those systems can't adjust on the fly. So, they often require reprogramming or redesigning, which definitely or ultimately leads to more time and money. So, while you mention about what the role automation plays in terms or the importance of automation in factories and warehouses, what makes AI powered vision systems more effective than the traditional and conventional, sensor-based solutions when in terms of identifying and solving these operational issues?
Yeah, so conventional sensor-based solutions, their logic is hard coded in the sense that the sensor will tell you when the object has arrived, right? The sensor will tell you can also tell you the orientation of that object, but if you change that object, it will not be able to work. What AI models enable is a wider flexibility. So, for example, Mowito has trained its AI model on millions of different products. We got the product from Kirana stores. We got the product from factories. We got the product from all walks of life. We trained our AI model. Now our AI model can, you know, detect any kind of object which is placed in front of it. You can throw any object in front of it, and our AI model can make the robotic arm pick it because of the position, orientation. I mean, they have sensors. You can get all the information about the object, but you need to hardcode the logic about, hey, this is a particular type of product which we are looking for. This is the kind of orientation we are looking for. These are the values which you need to achieve to do this and that task. Right? And that takes a lot of time to set all these configuration. And as soon as the product changes, you have to again reconfigure it. AI model, which especially the one which Mowito has made, since it has been trained on a lot of data, it is what we call foundational model, right? So since it has been trained on a lot of data, it can detect all kinds of object. All you need to tell is that what is the task it needs to perform. That's all. So whatever is object in front of you, you just need to tell, hey, you have to pick this object and place it there. You tell it once, right, which will take you roughly 20-30 minutes to do it, right? And it will be able to perform the task. So all you need to do, I mean, all it takes is 20-30 minutes to reconfigure it. And the reason it is able to do it because it has already been trained on so much of data that you do not need any more training for it. You do not need to set any new logic for it. You just need to describe the task. And you can describe the task using our user interface. And our user interface could be I mean, you can demonstrate the task. A human can show how it is performing the task. You can describe the task in natural language, and it will be able to use that. So all this reconfiguration could be done even by someone who does not have any kind of certification. So traditional system, for example, if you use a typical FANUC ABB KUKA robot, they have certification programs. So an engineer need to be certified by one of these companies to reprogram these robots. In our case, we have made the interaction so simple that anybody can reprogram the system, or describe the task which the robotic arm has to perform. And since it has the AI model has already been trained on so many objects, it can quickly be reconfigured using the task description to do the task. So this is what we do. And currently we are using just camera, but of course down the line we will be using other sensors as well. For example, there are force and torque sensors in every joint of the robotic arm. Right? We will be using those values. We will be using the tactile sensors which are on the gripper, which senses the force, and using that also to guide the robotic arm. We'll be using that to train our AI model, and AI model will in turn guide the robotic arm. So this is basically what we are doing, right? Training it on so much of data, then that now it can work on detecting any kind of object without any custom training. Using human demonstration, using natural language like typical English to describe the task, so that robot could be reconfigured very quickly within 5-10 minutes or maybe 20 without any specialized engineers, and using data from multiple sensors to train our AI model so that it has much general intelligence about the environment, so that it's not just using camera, it is also using other kind of sensors to understand the physical nature of the environment, right? So that's what we do basically. That's how
Right,
our AI
yeah.
model is better in doing the tasks than in typical traditional systems.
Great. Thank you for sharing that. Just like to help our listeners understand what exactly AI-powered vision software is, that in its simplest form, this allows machines to see and interpret visual data, much like the human eye and brain work together. But this software goes far beyond just simply recording images. It can analyze complex visual information in real time and make decisions based on what it sees. And with the help of machine learning, these systems get more smarter and accurate over time, depending on the data that you're feeding into these systems. So, like imagine a machine in a factory, it's equipped with a camera. So they can not only detect the presence of an object, but also can analyze its size, shape, color, and even the surface defects. So, or a robot in a warehouse that can scan a crowded shelf and instantly identify the correct product without any human assistance. So that's the kind of power that AI vision brings to the table. So, Puru, like you of course mentioned about how Mowito's AI vision technology is making a transformational change in the entire automation of in the warehouse and the manufacturing floors. So can you help us with some real world case studies or example as to how Mowito's solution has improved efficiency or flexibility in a particular warehouse setting?
Yeah, we have. I can't disclose the details about the warehouse deployments which we are having,
Definitely,
the
yeah,
POCs.
yeah,
But let me go towards the manufacturing side. We have.
yeah.
It's kind of in public news now, so I can release that information. So we are working with one of the second largest automotive manufacturer in the entire world, and they provide components for Suzuki, Toyota, Honda, and all those companies. Right, they're a Fortune 500 company, and there we have deployed our solutions for three purposes. Right? First is inspection. So typically, what you do is you put a camera on a conveyor line, on assembly line, and that camera takes the picture of the object and tells you whether the object is good or bad. Now, with a stationary camera, with a static camera, you can take picture from only one angle. What we did was we put a camera on the robotic arm. Now that robotic arm can take the picture of the item moving on the line from multiple different angles, right? And irrespective of how the item has been placed on the line, it could be in any position, in any orientation. Our vision system will be able to detect that position, orientation of that object, and accordingly adjust the angle from which the pictures have to be taken. So it can take multiple pictures of the same particular part from a single camera, right? Traditionally, you would have used four different cameras to take pictures from four different angles. Now we can use one camera and one robotic arm to take the picture from four different angles. The interesting part here is that even if you change the part from, you know, today you are making one particular product, tomorrow you are making another product. So especially when it comes to automotive part manufacturers. They make parts for multiple companies. So one product which is being made, like let's say shock absorber. Today they are making it for company A. Tomorrow they will be making for company B. Both will have certain differences. It will be the similar product, but certain differences, and they will be made on the same line. So what our inspection system can do is, based on what part is being manufactured, it will adjust the camera angle accordingly. So instead of putting, four cameras for one single part, eight cameras for two different kinds of variants of the same product, you just need to put one camera, one robotic arm, and it will do all the job. You can, even if you change the line from, even if you want to move the whole system to another line, you just take out the robotic arm and place it on another line. No integration required, no reconfiguration required. It will work right out of the box because it is that much independent. It is that much flexible. So that's one thing. Second deployment, which is it's actually an advanced proof of concept. It is close to being deployed. Is we place the robotic arm on the top of a mobile robot. So instead of robotic arm bolted at a single location, it is now moving around and it is feeding the raw materials to different machines. So it feeds the raw material to machine A, takes out the output from machine A, feeds it to machine B, takes out the output from machine B, feeds it to machine C, and so on. Traditional solution in traditional solution, robotic arm is bolted next to the machine. So one robotic arm only feeds the raw material to one machine. We put the robotic arm on a mobile robot, so it can move around and feed raw materials to 3 to 6 different machines. So we increase the usability of that utilization of that robotic arm. So one robotic arm is doing the job of 6 robotic arm, right? So that decreases the cost of infrastructure, that decreases the time to set up the whole system, right? And these machines could be very far and wide. So that's, and we are able to do it simply because our AI model can pick up the part from any position orientation, can work even when the robotic arm itself is moving, can work even when the robotic arm is not fixed, right? Because our AI model can work with dynamic scenes. So that's the second application. Third application is assembly. So typically what happens is, let's say you are in a factory which is making engines. Engine will be coming on a conveyor and it will stop at different station so that a human operator or a robotic arm can operate on it. That operation could be putting another part on the top of engine, right? In order to complete the assembly. So the engine has to stop at different station where a robotic arm or a human can operate on it or can place another part on the top of it. With Mowito, uh, the engine does not need to stop at any station. The engine can keep on moving and the robotic arm will still be able to operate on that. So that increases the production. So typically the engine had to stop. Typically the product had to stop at each station, which, and stopping takes roughly, could be anything from 5 to 10 seconds or 20 seconds, right? Depending on what kind of operation you are doing. But with Movito, the robotic arm can operate while the object is moving on the conveyor. So the conveyor does not need to stop. So it increases the production by 17% roughly. It depends on what production line it is, but on average, it can increase the production by 17%. Right? So that's another interesting thing. Simply, we are able to do it simply because our AI model can deal with dynamic environment, can deal with the objects which are moving, um, can deal with when the robotic arm can operate on the objects while robotic arm is moving or the object is moving, and can also operate on objects whose position orientation are not fixed or different kinds of object without any training. So these kind of qualities enable us to serve all these three applications, which no other company in the entire world is able to do. That's what sets us apart.
Great.
That's why our customer loves us.
Yeah, yeah. Thank you so much for, giving us a detailed overview of how Movito is different from the other automated solution providers and difference that you're trying to bring in the manufacturing sector. But again, I think we already have faced a lot of backlash in terms of automation that we are probably reducing our dependency on the human aspect. So there's a human factor, like factories and warehouses still require significant human oversight to ensure everything runs smoothly. Employees have to manage quality control or detect errors, and sometimes intervene within the systems that when they don't work as planned. And not to mention, they're also responsible for the physical aspects of moving products and materials around. So these challenges, like the lack of flexibility, low accuracy, and heavy human involvement, has made it clear that more intelligent systems are necessary for the next stage of industrial automation. And again, we discussed earlier, and you helped us understand that the power of AI-powered vision software. So, how does your software handle, the balance between a human and machine collaborations when we are trying to deploy such automated solutions?
Yeah, see, yeah. So what our system allows is that human and robot should be able to work alongside each other, right? And the whole idea that our system can work on dynamic objects came from the fact that when you're working next to a human will never place an object on the conveyor in the same position and orientation all the time, right? There will be some variation in the way a human does a task, even if it is done by a same human. So if I let's say if I'm working in a kitchen, if I'm making exact same food all the time, I still cannot make it, make it with my eyes closed, because whenever I place an object back in the shelf, it will be at some different position and orientation. So the way we allow the human and robot to work together is first making sure that the robot operates in a safe manner. Second, the robot is able to operate on objects when they're moving, when they're in different position orientation, to make sure it can work. It can work on the next to a human when human puts it in any position or orientation they want. Robotic arm is still able to continue the work. Uh, uh, because it's able to deal with the dynamic scenario. The third is the interaction between human and robot. Um, the robot, typically the traditional robots, they need specialized engineers, specialized operators to program the robot in a very specific manner. And these engineers, if you are in a big company, you will have those kind of certified engineers. If you're in a small company, you will need to call a third party to reconfigure the system. Now, by making an interface through which a typical human, typical person, typical factory operator can interact with the robot in a very natural language. So right now we work on English, but right now we are also creating an interface through which human operators can interact with the robot in the local tongue. Right? Let's say Hindi, Bhojpuri, Kannada, Telugu, and all these local languages, and can use that interaction to describe the task to the robot. So using that, we are trying to decrease the friction between human and robot collaboration. We are making sure that the human is able to describe the task to the robot in the local tongue, and robot is able to understand the task easily within 5 or 10 minutes of conversation. Finally, we are also working on demonstration learning, so that a lot of time it is easier to demonstrate the task than to describe the task. And this is how even human learns, right? Even animals, that's how they learn. You demonstrate the task to them, and human will be able to pick up the task. For example, folding a t-shirt, right? It's easier to describe how to fold a it's easier to demonstrate how to fold a t-shirt than to describe it. So we are working on solutions through which the robot can see the demonstration either through a video or through a live feed. It can see a human, let's say a human folding a t-shirt, and can from that learn how to fold a t-shirt and pack it. And through that, we believe we can increase the adoption of robotic arms by decreasing this whole friction between how a human has to describe the task. So we are first incorporating the feature to describe the task in natural language, local tongue, and then we are also working on incorporating the feature through which a human can demonstrate the task of folding a T-shirt, packing a box of mangoes, or different tasks. Demonstrate different tasks, and robots will be able to understand the task just by looking at a human demonstrating the task. And one thing to note is human has two hands to do the task. So what makes it challenging is how can a robot look at a human doing the task and figure out how it will do the task with one robotic arm, right? So that kind of transfer has to be done. And eventually, I mean, the eventual goal is that one robot learns the task and spreads that knowledge to all different kinds of robot. So that will be the, the peak of human robot collaboration, that one human demonstrate the task to one robot, and all different kinds of robot will be able to understand that and adapt it to their own hardware configuration or task configuration.
Right, definitely. That's a pretty fascinating aspect of Puru. And eventually, I think balancing human expertise with machine efficiency is crucial in modern automation. And, we really need to adapt to the dynamic nature of human decision making while also ensuring the precision of these automated systems. One last question for you, Puru. I think if somebody wants to ask what's next for AI-powered vision software in factory and warehouse automation, I think the future looks incredibly promising. And as AI models become more advanced and the computing power increases, we are only going to see these systems even more capable. So, what are your expectations or certain trends that you predict in terms of the broader adoption of these AI-powered vision software in factories and warehouses?
Yeah. So see, one thing is that through the vision systems, right? Vision system is basically having a camera which can give you the information about whatever the camera is seeing, and then AI model will use that to understand the environment and to figure out how to do a task, or figure out what is the task and then do the task. So the way it will progress, or the way my expectation is that, as I mentioned earlier, that the robot will be able to see a human doing different tasks and understand what is the task, and the robot will be able to adapt the task to its own environment. For example, a human describes a task folding one specific T-shirt, and all the robots in that garment factory can understand. Okay, that T-shirt was folded like this. I have a different kind of T-shirt. How can I adapt that technique of folding a T-shirt to the T-shirt I have? Right. So one T-shirt of small size. It was half sleeve. The human demonstrated on a small size half sleeve polo T-shirt, and now I have a V-neck T-shirt or a full sleeve T-shirt. How can I do that with that T-shirt? Right. Human did it with two hands. How can I do it with one hand? So that will be that's what I expect the vision systems or vision AI models to become. That one robot sees the demonstration and then adapts it to the task which it is performing, which could be slightly different tasks with a slightly different object adapted to what it is doing. Or, I mean, even outside the factories, even in kitchens, right? A human demonstrated how to make one particular kind of curry. How can that be adapted to make another kind of curry, right? Or in hospitals, right? You demonstrated it how to prepare the for the how to prepare all the tools for one particular kind of operation. How can you use that knowledge to prepare the tools for another kind of operation, right? Or you demonstrate it for a kid. How can you, transfer it to an adult, or vice versa, right? That kind of, if you can get, I mean, that's the kind of expectation I have from the vision systems. And of course, you, it's not just the variation in the task, it's also in the variation in the robot. So you described the or demonstrated the task for a single robotic arm, let's say, which is bolted on a table. But how can a humanoid use the learnings of a static robotic arm to do its own task? For example, you demonstrate the task of folding a t-shirt for a robotic arm which is bolted on the table. How a humanoid can also learn from the same demonstration, or how the learnings of that static robotic arm could be used by a humanoid, could be used by a robotic arm on wheels, could be used by totally different kinds of robots. So that sharing of the knowledge between different kinds of robots, that is another expectation which I have. And finally, I believe it's not about vision, it's about the AI model. So as AI model will become more and more multi-model, that means they will become they will be able to take in the data from different kinds of sensors. So vision is just one kind of modality. It's just one kind of sensor which is getting the data. Then eventually there will be tactile sensor. For example, if you pick up an object, even if I blindfold you, you will be able to figure out what is that object. You will be able to figure out what is the orientation of that object just by feeling it from your fingers. So what I expect down the line is that AI model will also get the data from the force sensors or tactile sensors in the gripper and be able to understand the nature of that object, whether that object is delicate, like a tomato or like a banana, or that object is hard, like a coconut. Right? We already do a part of that. We already figure out what is the hardness of the object, whether the object is delicate or not. It will further be refined once we start incorporating all these force sensors in the gripper, and we will be able to figure out all kinds of information, delicateness, position, orientation, maybe the size of the object, right? And adapt our task, adapt our trajectories, adapt the different aspects of the task according to that feedback. So down the line, what I expect is AI model will not only depend on the vision, but also on the force sensors, tactile sensors, and all the other kinds of sensors, maybe sound. Depend on the sound to figure out more about that physical nature of that object. So we call it physical AI. So the AI model will move towards the physical nature, physical AI of the world, right? And that is my expectation. So if you check the latest news, Meta has released models which can models and some sensors which can touch the surface and figure out whether that's what is that kind of surface it is. Is it velvet? Is it hard? Is it rough? Right? And once we reach that level, once this kind of things are refined, we will be uh, we will be able to get more and more information about our environment. And we'll be able to act accordingly. When I say we, I mean robot, of course. The robot will be able to
Yeah.
act accordingly.
Yes, and I think eventually AI-powered vision software is definitely a game changer for factory and warehouse automation. It's addressing the challenges that have long hindered operation efficiency while also setting new standards for what's possible. From improving flexibility and accuracy to reducing human dependency and error, I think this technology is paving the way for more smarter and more efficient industrial operations. Well, thank you so much, Puru. It was a pleasure having you with us on our podcast today, and thank you for giving such eye-opening insights about AI-powered vision software and how this technology is changing the entire reams of manufacturing and warehouses today. And hopefully, in the near future, we'll definitely have more flexibility and efficient industrial operations. Thank you so much, Puru.
Thank you.
Yeah, this is for our listeners. Stay tuned for more such episodes about how AI is transforming different industries. Be updated on our next episode, and you can view all our previous podcasts on Spotify and the leading platforms. Until next time, keep innovating and stay ahead of the curve. Thank you.